Find the equation corresponding with this line, we need to find a different approach. So now we have 2 points, and apparently for the equation I know that y would be something times x plus something else. So the gradient plus the intercept. Okay, I have 2 points, so apparently I know that 1 would be a times 2 plus b, and I know that 2 would be a times 4 plus b. Okay, that's nice. Again, we have 2 equations with 2 variables, so we can solve this. And let's use the elimination method because the b's are similar. So we just subtract the 2. That would mean minus 1 would be minus 2a. The b goes. So that means a would be a half. Oh, that's nice. So now I already have y being a half times x plus b. Okay, let's use this one in one of the equations. So that means 1 equals a half times 2 plus b. So 1 being a half times 2 plus b. Okay, so 1 equals 1 plus b. That means b should be 0. So the total equation would become y being a half times x. And again, you see now, because the b is 0, that this is a line going through the origin. Check this for yourself. We can also have lines in 3 dimensions with a vector form, and then it's just having 3 elements. So we have a x, a y, and a z. You have to have a starting point and a direction vector. So it's basically exactly the same as a 2-dimensional line, but only with one element added in the z direction. For example, if we look at this line, so we have x, y, z being some starting point plus a parameter lambda, which can be minus infinite until positive infinite, times 2, 0, 1. So if we can find some points on this line, so for instance, let's take the easy one, lambda being 0, then a point would be 1, 2, minus 3. Okay, let's take another easy one. Choose lambda being 1, then a point would be 3, 1 plus 2, 2 plus 0, minus 3 plus 1, minus 2. Or let's choose lambda being minus 2. Okay, so then we have 1 minus 4, we have 2, and we have minus 3 minus 2 being minus 5. So just by choosing different versions of lambda, we can find infinite numbers on this line. And just by connecting the points, we will have a line in a 3-dimensional space. We can't do, by the way, a linear equation. So in a 3-dimensional space, we only can use vector forms. Okay, if we have now the 2 lines in a vector notation, then of course we can also find intersection points. And so if we have a line L given with xi being 1, 1 plus lambda 2, 3, and another line M by xy being 0, 1 plus mu times 4, 1, then the intersection point would be xy, which is in line L as well as in line M. So if we can find a lambda and a mu in such a way that 1, 1 plus lambda times 2, 3 equals 0, 1 plus mu times 4, 1, then we have an intersection point. So if we see this, then we would say, okay, 1 plus 2 lambda would be 4 mu, and 1 plus 3 lambda would be 1 plus mu. And hopefully you immediately recognize we have 2 equations with 2 unknowns, so we can solve. So let's do a substitution for a change. So we'll use this one here to express the mu with the help of lambda. So mu would become 0, 1 goes to the left, mu would become 3 lambda. So 1 plus 3 lambda equals 1 plus mu means mu is 3 lambda. Okay, then if we substitute the mu in this expression, it would give us 1 plus 2 lambda equals 4 times 3 lambda equals 12 lambda. So apparently we have 10 lambda being 1. Dat is niet goed. Oh ja. So we have 10 lambda being 1. So lambda would be 1 divided by 10. Now let's make a small note of that. Lambda being 1 divided by 10. So if we then try to figure out the intersection point, we just use it in one of the lines. So xy, let's use it in the line L, would be 1, 1, plus 1 divided by 10 times 2, 3. So this would give us the intersection point 1 plus 2 divided by 10. So that would be the intersection point 12 divided by 10, comma, 13 divided by 10. So if we remember from the previous slide, mu was 3 times lambda. So mu would in this case be 3 times 1 divided by 10. So if we use the mu in line M, hopefully we get the same intersection point. So xy, the intersection point, would be 0, 1, plus 3 divided by 10 times 4, 1. Okay, so that would give us the intersection point 0 plus 12 divided by 10 and 1 plus 3 divided by 10, 13 divided by 10. And that's, thank God, the same point as we've calculated with the lambda parameter. So indeed, we have found an intersection point of the two lines. So if we have a vector form of two lines, L and N, if V and W, so those are the vectors of line L and the direction vector of line N, if they have the same direction, then of course they are in parallel. So they don't have an intersection point or they're exactly the same lines. So we only have an intersection point if the vector V and the vector W are in different directions. If we look in a three-dimensional situation, then of course we can have two vectors in different directions, but opposite to on top of each other. So just imagine you have two tables standing on top of each other. Then one of the vectors could lay like this on one of the tables, and the other vector could lie like that on another table, and then still they wouldn't meet because they're exactly on top of each other. So in a three-dimensional situation, it's quite possible that there is no intersection point, even if they have different directions. So let's look at these two lines. So we have a line L, which is 1, 2, 0 plus lambda 1, 1, 2. And we have a line M, which is 0, 3, 2 plus mu times 3, 1, 1. If we want to calculate the intersection point, then we have to say, okay, 1 plus lambda equals 0 plus 3 mu. And 2 plus lambda would be 3 plus mu. And then 0 plus 2 lambda would be 2 plus mu. So now we have three equations with two unknowns. So we can use two of them to solve the puzzle. So let's take these two. So I have 2 plus lambda being 3 plus mu, and 2 lambda equals 2 plus mu. If we subtract these two, then we will lose the mu. So that means 2 minus lambda would be 1. So that means lambda would be 1. Okay, then we can figure out the mu by just filling in the lambda in one of the equations. So let's do it in this one. So 0 plus 2 would become 2 plus mu. So now we calculate mu being 0. So far, so good. But of course, we have a third equation, and what we need to do now in a three-dimensional environment is check whether the mu is 0 and lambda equals 1 gives us a nice solution in the unused equation. So 1 plus 1 equals 0. Okay, we know that this is completely wrong. This is called a contradiction. So that means that these two lines do not have an intersection point. Okay, any questions? So please make the assignments, try to figure out how it works. On SharePoint you find lots of them with possible answers to them, and then we'll meet again in our meeting session on Teams.